All right, guys, I'm coming to you today from home during Lila's nap time. So we're going to do a quick video on reviewing average rate of change. This is something you definitely looked at in past years. We're going to build onto this next time I see you during class time, quote unquote class time. So the definition of average rate of change, you can see in front of you. It's the slope of a secant line for a function between x equals a and x equals b. And this is an important thing to distinguish. A and b are constants in this formula. All right, so they're a number that doesn't change. So x could be 5 and b could be 7, whatever. So they are constants. And if you think back to secant line, we go back to geometry, probably was the last time you've seen that. And if you remember your circle rules, a secant line was a line that cut through a circle in two spots. So that blue line there would be a secant line for that circle. So those are some important little distinctions to make. Okay, so average rate of change is really the same thing as slope. All right, same thing as slope. So we're thinking change in y over change in x. We're thinking rise over run. We're thinking y2 minus y1 over x2 minus x1. That's really all you need to know for this formula. But let me kind of show you what it looks like with a nonlinear function. So that's the nice thing about this average rate of change. All right, we know what a slope would look like. If we just have a linear equation, y equals, we're going to see one in a minute like this. What's the question? 5x minus 7. So y equals 5x minus 7. There's my y-intercept. Pretty steep slope, up 5 over 1. So if I look at that, we know the average rate of change. We know the slope. We know the rise over run. It's just up 5 over 1, up 5 over 1, up 5 over 1. So there's not really any need to do the formula if we have a linear function. But for a nonlinear function, so like the example I have over here on the left, and I know there's not a place in your notes to draw this. If you want to sketch this in, if you have some space, that would be good. So for this nonlinear function, so there's x equals a and there's x equals b. So again, those could be constants. I'm sorry, they have to be constant. So that they could be 1 and 5. A equals 1 and b equals 5. That kind of looks like where it is on my x-axis. All right, but either way, those two values are actual numbers. So I'm just going to call them a and b now just to generalize this formula. So this secant line, or this slope of a secant line going through those 2 points would look something like that. So what the average rate of change does is it will give us the rise over run, so that average rate of change, the slope, between 2 points that are not necessarily on a straight line, obviously. So if we think about what this is, if this point on my graph is A, this spot on the y-axis will be f of A, right? There's my output. So my input is A, my matching output, my corresponding output is f of A. Same thing here, there's f of B. Okay, so hopefully that makes sense. There's B. If I go up to that point, there's f of B. So the formula, this rise over run, is really just y2 minus y1 over x2 minus x1. So literally, there's my y2, there's my y1, there's my x2, there's my x1. So we're just going to use function notation. All right, so that's all it is. It's the rise over the run between these 2 points. So going back to our notes here, the average rate of change, the formula that you will see, average rate of change, instead of y2 minus y1 over x2 minus x1, we're just going to call it f of b minus f of a over b minus a. So there's your average rate of change formula. All right, so let's do a kind of an easy one first. Find the average rate of change for 5x minus 7 between the points x equals 2 and x equals 4. So looking at this one, this is the example I just talked about. We should know the answer to this already, right? The average rate of change of a linear function is always going to be the same, no matter what 2 points I pick, right? No matter what 2 points I pick on this line, the average rate of change will always be the same. But let's just test our formula. So f of b minus f of a, I guess to make it easier, we'll just call that a and that b. So really all it is f of 4 minus f of 2 over 4 minus 2. So we can, quick do a little substitution there. F of 4, 5 times 4 is 20. 20 minus 7 is 13. F of 2 is 3 divided by 2. And it checks out. So there's a little bit of mental math there. And that makes sense. The average rate of change between those 2 points should be 5 because it's a linear function. So let's take a look at our last example. I changed the numbers here, so just be aware. I don't like the ones we had there. So I'm going to pick those two for my A and B in this case. All right, so the average rate of change for 2x squared plus 4x minus 3 between x equals negative 2 and x equals positive 2. So I sketched the graph here for you. I know it's not on your notes, but it's kind of neat to see. So there's negative 1, there's negative 2. So right here is f of negative 2. And positive 2 is, looks like it's going to be a little off our screen, right? So it'll be up here somewhere. So if you look at what's happening, this average rate of change between these 2 points, so just the average rate of change, so what's happening between those 2 points, it's growing at a pretty steep rate, right? It's rising quite a bit compared to how much it's running. So the average rate of change is going to be pretty big. But what I want you to start thinking about for next class is that's not a great picture because this graph is doing a lot between negative 2 and positive 2, right? It's going down, it's actually leveling out for just a split second, and then it's increasing quite a rapid rate from 0 up to 2. So even though that secant line kind of gives us a picture of what's happening, it gives us the overall trend, it's missing a lot of the detail, the nitty-gritty in between those 2 points. Okay, and that's what we're going to kind of start to look at next class. How can we make it more accurate? So why don't you guys, you can pause this. I actually don't have this one done since I changed the numbers, but you can crank this out, f of b minus f of a over b minus a. And just like any slope formula, it doesn't matter what I choose for a and b, as long as it's consistent in the numerator and the denominator. All right, so either way, f of b minus f of a over b minus a, doesn't matter which ones you pick. I'm going to pause just so I can do this because I know you guys don't need me to do this math, but I will unpause just to make sure we're all on the same page, and then we'll move on. Okay, so doing a little bit of math, simplifying, we see the rise over the run. So the average rate of change from negative 2 to positive 2 is up 4 over 1, up 4 over 1, up 4 over 1. So the average rate of change is 4. But like I said, there's a lot more going on here. It goes negative for a little bit, and then it levels out, and it goes really positive. So it would be different. Let's say I picked negative 2 and negative 1, right? If I picked these 2 points for my average rate of change, it would look a lot different. My slope would actually be negative there. So this average rate of change is nice to get a general snapshot of what's happening between 2 values, but we can do a lot better. And we're going to talk about that next time. So if you want to try this next one out, you can. Let's see, the answer, I have my key for that one over here. The answer to that one, I don't have my key for that one. Oh well, but you guys can do it if you want. But that's all. So make sure you do the Google form that goes along with this. And that is all for this video. All right, I will see you guys in class. Have a good day. Bye.